So in the first traversal, we have three types that have three different ways. We call preorder, inorder, and postorder. Preorder, inorder, and postorder. Here we focusing on our data, whether we display our data first, we later display our data, or we display it in order. So normally it follow this format we call DLR, data left right. So data here, okay, left here it go to left sub 3 and right sub 3. Data here we actually the root, right? Because when we have this one, okay, left and right, right, left and right, and this one is root, so we can access to this data. So the rule is that you access to root data left and right. Okay. So considering on this one, okay, if we display, we access to our data on this tree using the preorder traversal. Okay. So the rule is that root data first, left and right. Okay. So now if we focus on here, right, this is root right, F right. So it means that we can display letter F here. Okay. And next, if we go to left, okay, the rule is root data then left. So here left, right, here is left. But if we focus on the left here, we can see that, okay, the root data now is D, we can display D, okay, D. So after this one, what is the left here? After root data, we go left, right, still go left, right, until left finish, then we go right. So now left here is D, because D has also another subtree below it, so it will go to the left here. So the left here, right, B, so we get B, and then the left next is A, okay. So now the left is already done, we will go to the right. So because now we are here, we need to access to the right from here, right? From right here. So now we got C, and then what is the next right, which is E, right? Okay, E. So it means now left are finished. Now we go to the right. Considering on the root here, the left subtree here are already visited, right? We can display all our data already. And next we focus on the right. Okay, now left finish. Now we go to right. So when we go to right here, okay, we will get letter J, right? Letter J here. And next, because this one it also have left and right, right? So after this one, it will visit the left here. Okay, this is the left. Following this format, data left and right. So we will get letter G, okay, letter G here. So let's say this one is just something deleted. So G, okay, after G it should go to the left, right, letter left here, but it has no data. So now we go right of it, which is letter I, okay, letter I here, and then left of this node, which is H, okay, letter H here. So now the left is finished, we go to the right, which is K finally, okay. So this is our output data when we use the preorder format. The rule is very simple. You focus on the DLR, data left and right. So to implement this in code, very simple. We create a function very short. Maybe we need 5 lines. We use a name, okay, preorder, and then we must provide the root of the tree. And then the rule is that we will recursively access to our data. Based on the rule data left right, it means that when we check here, condition is we try to loop until nil, okay. And then recursive, before recursive, we display our data because we meet data first, left and right, okay, left, recursive right. So this we call to this function again using recursive format. Go left and then go right. Okay. This way we will access to our data using this format, just like we go through together recently. Okay, next we will go into another type of tree traversal called Inorder. Okay. So in Inorder, it follow the format LDR, left, data right, because when we have a tree here, if we say Inorder, it means that we go from left to right, and then we get this one, get this one, get this one, right? Okay. So this is left subtree, this is our data, and this is right subtree. So focusing on this tree example, okay, if we use Inorder traversal, what are data that we will get? Okay. So first we start from the root here, right? So root here, it have left and right. This is left, this is right, right? So we're still not able to get our data yet, because if we focus on this root left, okay, this is left of the root F, right? But if we focus on this subtree, B is also another root, right? It's not the left yet, so we still go into the left. Okay, try to reach it left, and now we are reaching B. Okay, but B here is also considered as another subtree. Okay, yes, you can see here, so it means that B is the root, so we cannot display B yet. Now we go next to the left. Okay, the rule is left data right, we go to left, so left of B here is A. Okay, left of B here is A. Okay, letter A has no other left or right, so we display A first, so we get A. Okay, let's say put it here, so we got letter A. So based on the rule, left, root data, and right. So after left here, its root is B, right? This is B, so we get B here, and then it right. So what is the right of this one? Is C, right? Okay, C. So this one is finished. Now we go up. This left subtree is already done, right? This left subtree is already done. So we go up, left, and then root data right. Okay, it roots of B is D, right? Okay, and then we get D, and then right. Okay, right is E. Okay, this is the number that we get. And next we go up. Okay, this subtree is already done accessing the data. So next we go to the root. Okay, left is already finished. Now we go to the root. Data here is F, right? Okay, so we get F. Get F here, and next we go right. It is here, right? But when we are here, we still not able to get this letter J yet. It's because that, considering on the right subtree here, we have this is called consider subtree, right? So J here is actually a root. We have left is J and the right is K, right? So following our rule, left data right. So while we are visiting J, we cannot display J yet. We must go to it left. Okay, based on rule is left. So left it called G. Okay, G is left. It's because G has no data on the left. So following the rule, okay, it has no data, and then it access to root, right? Which is letter J itself here. Okay, so G here we can display it. We can display G. Okay. So after G, it is root data here, and then we can go to the right. Right is I. While we are visiting I here, I is also another subtree. Okay, I is a root. It left is H. So it means we display H, not I. Okay, based on rule left data right. Okay, so we display H first, and next we go to this root I here. So display I. So the left is finished, right? The left is finished. So now it means that we are finished this side. This side is finished already now. Okay. So left is finished based on the rule here, left, root data, and right. It means that now we should access to its root. So based on this subtree, the root is J, right? Okay. So after I, we get J, and finally the last node here, which is K. Okay. This is how our method to access our data and using Inorder. So normally if we apply to BST here, the data that we use to display using the Inorder traversal, normally it is displayed as the sorted order. As you can see here, A, B, C, D until J until K. If we store the number, okay, we will sort in the order. And there are some rules also. For example, the way we store our data should not be redundant, not duplicate, or we allow it, whether it go left or right, it's up to our decision design during the implementation. Okay, so at this point, okay, when we create a function, very simple, right? We only need about 5 lines. So we put our order using this format: left data right. So data means we display it, left we recursive left subtree, right we recursive to right subtree. So our rule is root not equal to nil, and then this we recursive to left when we pass the left node of the root, right? So we recursive left, we display data, and then we recursive right. Okay, using this rule format. Okay. Left data right. So based on the recursive function, it will get all our data needed here. Okay. So later on we will implement them together in our codes to see whether we get the same result. Okay, next the last method in the our display method. We call post order traversal. So in post order, it means that our data go to the post processing. It means that it go less first and then right and then data at the end, because we call it post, right? Post, we consider our data display is lastly. Okay, so left sub 3, right sub 3, and then our data. Okay. So if we focus on this 3, we see that the root is f, right? Root is f. Based on our rule, we left sub 3, right sub 3, and our data on the root. So it means that we must recursive left. Okay, left here. Okay, left. So when we are now here, we are reaching this node, right, which is D. So D is still the root of, considering on the sub 3, D is still the root, right? So we still go left. Okay, so left here B, and then left here A. So A now, okay, we can display A because A has no other data, okay, and no other child. We can display A. So in A here, after A, we go right, right? So right is C. Okay, this sub 3, the node A is considered as a child of B, and its sibling is C, right? So after A, we go right. Okay, go right, which is C, right? So after A, we got C, and next we go to our data here, right? After left and right, we go out to data. So focusing on the A and C children here, it go to parent, which is B. Okay, we get A, C, and B. And next, okay, this left is done. So now we go to the right, because on the rule we go after left, we go to right. After this sub 3, we go to the right. Okay, the right is here, right? E, right? So we got E here, letter E. And then, okay, right here is now done. We go to our data here, which is D, right? Based on this sub 3. Left and right already visited. Now we visited the data, which is the root, right? Is the root. So now we get D. Okay, D. After D, because D here is considered as the left of F, right? The root F here on the top level. D is the left sub 3, right? So after left, we go right, right? So F not able to display yet. We need to access to this one. Okay. So when we consider on this sub 3 on the right, after left, we go right, right? After left, we go right. So now we are in node J here. Because J here is a sub 3, J is the root, and the left is G, right? So based on the rule, we go to left. Okay, so left here. So because G here, it has no left, right? So no left. So it means that left is done. Now it go to right. The right of G is H. Okay, H. Now it reach. The right of G is I. After I here, because I here it has also it is also a sub 3, in which it has the left node is H. So it means that I cannot display. Now we go to left. Go left here. Based on the rule, left, right, and our data on the root. Because now here is a root, we must go left. So which is H. We got H. Because H has no other child. So left is done. You go right. Because right of I here, it has no data here, right? So now we can display I. And then this is done. We display G. Okay, G. After G, we display right, right? Because considering on this sub 3, the sub 3, I is the root. The right of G is K, right? So we got K. Okay. And then right is done based on rule left right data, which is J now. And lastly is the here EF, right? So root is become to the last data in our access, our visit here. And we can see this is our output using the Postorder format, left, right, and data. It is a little bit quite confusing. However, if you follow this format, it's very simple actually. We go to start from root, because root here it has left. Okay, you go to left. So while we are here, whether we can display it or not, it's because this is also considered as the root, right? So it has its left here is also another subtree. So we still repeat the same thing until we reach the one that has no other children, which is the left. So the rule we implemented it is very simple. We just put the name Postorder here, we pass the rule, we check until it reach the leaf node, which is not equal to nil, and then our rule is that we go left, recursive left, we pass the left node right, which is we try to access to the left subtree, and we go to the right, we pass the right root right here, and lastly is our data, we display our data. So with these simple steps, we can access to our data using this Postorder traversal. This is the rule that we need to remember. Post data, it means that our data should be displayed lastly. Left, right, and then our data. Perhaps you can practice on this, on how you can access to the data in here using the preorder, inorder, and postorder here. And this is the result finally that we get after we implement the program. You can also try to check it manually why we get this number, using the method step by step as we present earlier.